Hey, welcome to the Explainer. On a ridiculously hot day, there is nothing, and I mean nothing, like walking into a cool, air-conditioned room. It's just instant magic. But have you ever actually stopped to wonder what is going on inside that box to make that happen? Well, today, we're going to find out.
I mean, really, think about it. How does that simple box turn a hot, sticky room into a cool paradise? It feels like a miracle, but it's really just a brilliant process of moving heat from where you don't want it to somewhere else. So today, we are pulling back the curtain to understand exactly how your AC does this.
So here's our game plan. We're going to start with the secret behind it all, what I'm calling the 4-step heat taxi. Then we'll see how that idea scales up from a single room to giant skyscrapers. After that, we'll learn to speak the lingo, and finally, we'll wrap it all up with a quick pop quiz to see what you've learned. Let's get into it.
Okay, let's jump right into the heart of the machine. Every single air conditioner out there, whether it's tiny or massive, works on a principle called the Vapour Compression Cycle, which, sounds complicated, so we're going to use a much simpler name for it. The easiest way to picture this whole thing is to think of a heat taxi. There's this special fluid inside the AC called a refrigerant, and its only job is to act like a taxi. It's constantly doing a loop, picking up the heat from inside your room and then driving it outside and just dumping it. Simple as that.
And here are the 4 stops on our taxi's route. Step 1, inside your room, in the evaporator. The super cold liquid refrigerant soaks up your room's heat. This heat makes it boil and turn into a gas. Step 2, the compressor. Well, it does what it says. It squeezes that gas, which makes it really hot. Step 3, that super hot gas travels to the outdoor unit's condenser, where a fan blows air over it, releasing all that heat to the outside. This cools the gas back down into a liquid. And finally, step 4, the expansion valve releases the pressure, making that liquid instantly super cold again, ready to go back inside and pick up more heat. It's just a non-stop, beautiful loop.
So that 4-step cycle, that's the key to everything. But okay, how does that same basic idea work for not just one room, but an entire skyscraper?
Well, it's pretty obvious that cooling one bedroom is a totally different problem than cooling a giant shopping mall or a hospital, right? The physics behind it is exactly the same, but the engineering, the hardware, that has to be scaled up in a massive way.
And this table here breaks it all down perfectly. For single rooms, you've got your normal window or split ACs. We've all seen those. Now for something like a mid-sized office where everyone wants their own temperature, you use a VRV or VRF system. That's one big outdoor unit that can power lots of individual indoor units. For huge places like malls or airports, you need a centralized system. These have a giant chiller that cools water, and that chilled water is then pumped all over the building. And for medium-sized spots like a big store, they'll often use a package unit, which is basically a giant AC box sitting up on the roof.
All right, so now you get the process, and you know about the different types of systems. It's time to learn how to talk the talk. When engineers and technicians talk about air conditioning, they use a few key terms that are actually really helpful to know.
First up is the ton of refrigeration, or just TR. This is the main unit for measuring cooling power. And where it comes from is pretty cool. It is literally the amount of cooling you'd get from melting 1 ton of ice over a 24-hour period. Wild, right?
So, to put that into terms we might understand a little better, 1 ton of refrigeration is equal to about 3.5 kilowatts of electrical power. This helps connect that cooling power to, your electricity bill.
Okay, next up is COP, or coefficient of performance. Now this one is super important. It's basically the efficiency score. It tells you how much cooling you get for every bit of electricity you put in. All you have to remember is this: the higher the COP, the better. A higher number means a more efficient AC that saves you money.
And if you've ever bought an appliance in India, you've definitely seen those star ratings, 1 star, 5 stars. Well, for air conditioners, that rating comes from the ISEER. It's the official efficiency score that the Bureau of Energy Efficiency uses, and it's what tells you if you're buying a super efficient 5-star unit or not.
Okay, you've soaked up a ton of info. So are you ready to put that knowledge to the test? Let's do a quick 5-question pop quiz just to see what's stuck. Don't worry, there's no grade. It's just for fun.
Question 1. A ton of refrigeration is the melting of 1 ton of ice in A, 1 hour, B, 12 hours, C, 24 hours, or D, 7 days. What do you think?
And the answer is C, 24 hours. That's the standard time frame they use to define that basic unit of cooling. If you got that, awesome start.
All right, question 2. In those huge systems from malls and hospitals, what does AHU stand for? Is it A, air heating unit, B, air handling unit, C,
automatic humidity utility, or D, atmospheric heat union?
The correct answer is B, air handling unit. That's right. These are the big units spread throughout the building that actually handle the air and cool it down using that chilled water.
Okay, question 3 is a practical one. Say you have an office, and you know how it goes. Some people are always hot, some are always cold. Which system is designed for that problem? A, window AC. B, central chiller plant. C, VRV/VRF system. Or D, a desert cooler.
And you got it. The answer is C, the VRV or VRF system. That's the one we talked about where one outdoor unit can power multiple indoor units and each one can be controlled separately. Perfect for office peace.
Question 4. This one tests your memory of the cycle. The expansion valve is located between the A, compressor and condenser, B, condenser and evaporator, C, evaporator and compressor, or D, the thermostat and the fan.
The answer is B. It's right between the condenser and the evaporator. It's that critical final step that gets the refrigerant super cold right before it goes back inside to absorb more heat. And our final question. In one of those massive centralized systems, what is the medium that actually carries the heat from the air handling units back to the main chiller? Is it A, refrigerant gas, B, chilled water, C, compressed air, or D, liquid nitrogen?
And the answer is B, chilled water. So how'd you do? Hey, whether you got 5 out of 5 or just learned something new, you now officially know how air conditioning really works. From that simple heat taxi cycle to the gigantic systems that cool our biggest buildings, it's all built on that same elegant idea of moving heat. And that leaves us with one final thing to think about. Now that we know how this works, what's the next big leap? How do we keep our world comfortable but do it sustainably? Thanks for tuning in.